Hi, I'm Pradeep, and welcome to this lesson on abstract classes and interfaces. In this lesson, we will see what abstract classes are, what abstract methods are, and abstract methods as a contract between design and implementation, how abstract methods get used in polymorphic invocations, what interfaces are, and how interfaces serve as a contract between design and implementation, and the two roles that we play of class creator versus that of a class user, and how interfaces are used to define broad abstractions, and the idea of programming to an interface versus programming to an implementation, and how we can support, in a way, multiple inheritance using interfaces. Firstly, let's look at what abstract classes are. An abstract class is a class that exists only as an idea or as a concept, and in the real world, you cannot find any instances or objects of that type. Therefore, an abstract class cannot be instantiated. You can't create an object out of an abstract class. Objects always exist in the form of one of its subtypes. Specialized subclasses, which are concrete, can only be instantiated. So therefore, in a way, abstract classes serve as a placeholder for common structure and behavior, which all of its subclasses share or reuse. An abstract class in Java is defined using the abstract keyword in the declaration of the class. So as you can see in this example, we are declaring the class person to be abstract. Now, because of declaring this class person to be abstract, in the right hand side, you can see we are trying to create an object out of it. So if you try to compile this code, it's gonna return an error saying you can't create an object out of this class. It is the right hand side of the assignment operator equals that is going to return an error, not the left hand side. Remember, the left hand side of the assignment operator creates a reference. It's the new operator that actually creates an object. So therefore, what's the point of this abstract class if we can't create an object out of it? So in all other respects, that class looked like any other class. So why did we mark it as abstract? So we mark a class as abstract to prevent an object of that type, to prevent that class from being instantiated, and to capture all the common structure and behavior in a base class so that it can be reused by all the subtypes. Actually, the second bullet point is true about all classes. I could have used even a non-abstract class or concrete class, as we call them, to capture all the common structure and behavior in a base class. But if the class was not abstract, then you can instantiate it. Now, let's try and understand this a little better. Let's say we have a hierarchy like this. We have a class called vehicle, which provides the common structure and common behavior, which is common to all types of vehicles, such as, it has an engine, it has a fuel tank, it has some internal functions like pump the fuel from the tank, and so on and so forth. And then you have specific subtypes of this abstract class, like car and truck, which extend from vehicle, and they add their own functionality. Now, this hierarchy could have been created even without the abstract keyword in the base class, even if this class was just declared as vehicle. And also you see that I don't have any abstract methods. It's a common misconception that abstract classes must have abstract methods. No, you can have an abstract class without any abstract methods. So coming back to that point about why did we make this abstract? Now, come to think of it. Let's say if me and you were to go out onto the street and I were to ask you a very simple question, hey, show me a vehicle. What would you show me? Probably you'll show me a car, you'll show me a bus, you'll show me a truck. What if I were to say, hey, don't show me an object of car, bus, or truck. Instead, show me an object which is just a vehicle, but not a bus, not a car, not a truck, none of these. Would you be able to show? No. What that means is, vehicle exists as an idea to group together the commonalities found between car, bus, truck, bus, and so on. But in real world, you don't have direct instances of type vehicle. So therefore, does a class called vehicle make sense? Yes, it does, because classes capture ideas or concepts. But does an object of vehicle make sense? No. In real world, you don't have an instance of vehicle. So therefore, such classes which exist only as an idea, whose instances should not be created, are what we make as abstract classes. So that's what is an abstract class. Now, moving on to the idea of abstract methods. An abstract method is a method with no body or no implementation. Another way of looking at abstract keyword is in a sense to mean incomplete. Since abstract methods have no body or no implementation, that method can be considered incomplete. So whenever a class contains an abstract method, that class itself must be declared as abstract. For example, consider, let's say in a banking application, we have this concept of an account. Now, there are different types of accounts. You have savings account, you have current account, you have corporate account, and each account has some logic for its opening and closing. But the exact procedure or the logic for opening and closing of the account is completely different for savings, completely different for current, and completely different for corporate accounts. But nevertheless, we do have this open and close methods in the account base class. So what should be the implementation of this open and close method in the base class level? Well, you could say leave it empty, but you can't, because if you leave it empty, the child class author may not provide an implementation specific to that type of child class. So therefore, when you can't think of an implementation for a method at the level of abstraction, a higher level of abstraction that you're dealing with, you would mark them as abstract methods. So here is how abstract methods look. So we made these two methods abstract. Therefore, the class itself must be made abstract. And when we create these specific subclasses, such as savings or current accounts, the compiler forces us to override the inherited abstract methods. That is, since we are inheriting from account, it forces us to override the open and close methods. So, as I said, abstract methods are like incomplete methods. Abstract classes are like incomplete classes. And when we create a concrete subclass, that is a non-abstract subclass from an abstract class, we are forced to complete the incomplete portions from the base class. So these are concrete methods which override the abstract methods from the base class. So that's the idea behind an abstract method. So a class with one or more abstract methods must be marked as abstract. Another example could be, we all use these instant messaging kind of apps, such as WhatsApp and Viber and such applications. To capture the commonalities of all messages that are received in that app, we can create an abstraction or an abstract base class called message. But how to render a message? The specific logic for rendering a text message is different from the logic involved in rendering a file message versus that of an audio message. So we could make this show message method in the base class abstract, forcing the subclass authors to provide implementations which are specific to that particular type of message. And we make the class abstract and the method abstract, and we can create n number of subclasses. The beauty of this abstract methods and abstract classes is that even though you cannot create an object out of it, out of an abstract class, you can always create a reference of it. For example, notice here we have created a class called message receiver, and this message receiver class has an onMessage method. Let's say this onMessage method gets called every time there is an incoming message. Now, to receive that message, notice we are creating a reference of the abstract type. So which means, as you must have learned in earlier lessons, a reference of a base type can always be used to hold an object of a child type. So on that reference, we are invoking methods. So even though the reference is of type the abstract class message, the actual object at runtime is going to be of type a text message or a video message and so on. Now, even though the compiler knows that showMessage is an abstract method, it allows me to call it because it knows that at runtime the object will be of a concrete type and it's going to polymorphically dispatch this method call onto an appropriate object. So which means this onMessage method can get called with a text message object or a file message object or a video message or an audio message, and it will be this method call message.showMessage will be dispatched polymorphically to that concrete implementation of the showMessage method. So that's the idea behind abstract methods. They are designed to be polymorphically invoked. So an abstract class is a class that cannot be instantiated. An abstract class can contain both concrete methods as well as abstract methods. An abstract method has no body. It just has the method signature, so to say. Abstract methods in an abstract class need to be overridden by its subclasses. So that's the idea behind abstract classes and abstract methods. So we also have important concept of interfaces in Java, a very important concept of interfaces. Think of an interface to be very similar to a class. It's a group of related methods, but all the methods in an interface would automatically be considered abstract. So you can say, therefore, a class which you are about to design with only abstract methods can conveniently be defined as an interface. To declare an interface, you use the interface keyword rather than class keyword. As I said, it's very similar to classes. Interfaces go into their own .java files, compile into their own .class files, and just like how classes belong to packages, interfaces belong to packages, and interfaces are reference types, which means you can create references of type the interface. So they are very similar to that extent to classes. So here is how you declare an interface. So here we're declaring an interface called char sequence, and we're declaring a couple of methods, and automatically these methods are abstract methods. Not only abstract, they are also public and abstract. An interface, any method declared in an interface is automatically public and abstract. So once you've created an interface, how does a class use that interface? Like how you have inheritance among classes, a class can inherit from an interface, but we don't use the keyword extends. Instead, there is a specific keyword called implements. So a class is then said to implement an interface. This is also an easy relationship, just like inheriting from a class. Class string implements char sequence. In English could be said as string is a char sequence. So whenever a class implements an interface, it has to override all the inherited abstract methods from that interface. So all the methods that were declared in that interface, which were abstract, must be overridden by the class which is inheriting the interface. So since string is implementing char sequence, string is made to override these two methods, char@, and length methods. So when you define an interface, you are actually defining a new reference data type. It's very similar to defining a class, but it's just that it happens to be an interface. Just like how you can create a reference of a class, you can create a reference of an interface. For example, here we're creating a reference of the interface, char sequence CS. The left-hand side is a reference. But since an interface contains abstract methods, it's incomplete. You cannot create an object out of an interface. But a reference of the interface type can be used to hold an object of any class that implements the interface. So if our string class implements char sequence, then a reference of type char sequence can be used to hold an object of type string. So as you can probably think, very similar to abstract classes, these interfaces are also used for polymorphic invocations. So an interface, we also say, serves as a contract between design and implementation. So if you have an interface which have 5 methods, and let's say a class wants to implement that interface, then that class must implement all of the methods present in that interface, which means it must override all the methods present in that interface. So think of an interface to be like a contract. So the class which implements that interface fulfills the contract by overriding all of the methods. And some user or invoker which creates a reference of that interface type, or has a method which takes that interface type as an argument, or has an instance variable of type that interface, depends on that contract. And an object of any class which implements the interface can be used in place of that interface type reference. So an interface is a contract. It's a binding between the interface and the classes that implement those interfaces. So an interface serves as a contract between design and implementation. At design time, we can discover what functionality needs to be achieved and specify it as an interface. And for different possible implementations, we can have different classes implement that interface. So to the user of those classes, all those classes look similar because all of them implement the same interface. So implementing an interface allows a class to become much more formal about the behavior that it promises to provide. And interfaces form a contract between the class and the outside world. And this contract is enforced at compile time by the compiler. So if a class claims to implement an interface, all methods defined in that interface must be overridden in that class. And also a minor point about the variables declared in an interface. All variables or data members declared in an interface automatically become public, static, and final, which means you can't really have variables. You can just have constants declared in an interface. So interfaces are often used to model broad abstractions. Remember, abstraction is the public view of an object, the view of an object as seen by the object user. So when you have multiple teams working together and one team produces a class which another team must use, how do we kind of define a standard between these two modules or these two teams? So by defining an interface as an abstraction. So interfaces are often used to bring about such abstractions. So define the abstractions. To define the abstractions, we make use of interfaces. For example, come to think of it, let's say there is a class creator who wants to create different types of stacks, and there are users who want to use these stacks. Stack is a data structure, kind of a last in, first out data structure with a push, pop, and all these kind of methods. So the class creator could define an abstraction or the idea of a stack in the form of an interface and define the methods which are common to all stacks in the form of push, pop methods. And the class users would rely only on that abstraction. And then the class creator could define multiple variants of that interface. Maybe there's a fixed stack with a fixed size. Maybe there's a dynamic stack which has a variable length. So the users need not be concerned with these implementation because they can create references of type just stack S1, stack S2. And at runtime, the values or the objects that these references point to could be different objects, different instances of classes which implement the stack interface. So often, interfaces are used to define abstractions. So class users are abstracted from the implementation detail. So as much as possible, therefore, whenever you make use of classes which implement interfaces, the references that you create should be of type the interface, even though at runtime the object could be of type the concrete classes which implement the interface. So it's considered a good practice to program to the interface. So we say that it brings about loose coupling. Programming to the interface is also known as loose coupling. The advantage being that a change in the implementation would not have an impact on the client code, because client code would have only the interface type as the reference type. And although Java does not allow a class to inherit from multiple base classes, a class can implement multiple interfaces. So therefore, whenever it implements multiple interfaces, it has to override the methods from all those interfaces. So this, you can say, is in a sense Java's support for multiple inheritance. Right, so therefore, to summarize, an interface kind of defines a protocol of communication between the object user and the object. Interface declaration contains just the method signatures, but not the implementations. And a class which implements an interface must implement all of the methods declared in the interface. A class can implement multiple interfaces, and interfaces are used to define broad general abstractions. Always remember to program to the interface and not to the implementation. That's the end of this lesson. Thank you.